Hello, my name is John Pacey. I'm the Director of Cloud Development here at Wolfram Research, and today I'm going to give a talk about the state of the Wolfram Cloud. I've given talks like this before, and it'll follow kind of a similar format as that. So today, what are we going to talk about? Just give a brief overview of sort of what's new in the world of cloud notebooks in particular, cloud overall and beyond. We'll give a brief update on the ongoing improvements, including with our enterprise support and custom applications built with the Wolfram Cloud and related technology. So I'll give a brief review of Wolfram Cloud capabilities. I'm also going to explain some key features of the Wolfram Cloud environment, in particular some differences between the cloud environment and your typical desktop environment, and go over a quick brief overview of our roadmap and priorities, and then I'll handle some questions. And then also a reminder, we have a office hour for Wolfram Cloud immediately following this talk as well. So definitely another place to send us questions or hop in and ask some things there. All right, so the Wolfram Cloud, let's kind of go there. So I'll switch to doing that. And again, as Stephen and other people maybe showed off for different things, the main thing of our Wolfram Cloud is the typical notebook interface. I have a notebook here. I have a kernel. I can make evaluations. This one is very, very simple. And we can plot some graphics. My favorite graphic. We even have graphics 3D and some other things there. And so we've brought the desktop notebook interface to the cloud. And again, it's not a desktop replacement, but it is still very, very handy. And we'll talk later about different additional applications we can do with that. And more than just notebooks, we have the entire cloud object system and can talk about different things there. So I'll switch back to my presentation. So again, you can work with notebooks and write Wolfram language code in a web browser, as I just showed. You can share interactive notebooks and other content. This is very key. So it makes it very easy to share, in our case, notebooks. You can share packages. You can share arbitrary other content like HTML pages, images, different things like that. There's an entire permission system that allows you to control who can view it or edit it or other things there. You can deploy applications written in the Wolfram language. You can specifically deploy API functions or form functions and different things there. And it's a really good way to create these very powerful, pure cloud and also hybrid desktop or cloud workflows. And also, as we'll get to a little bit later in my talk, I'll show examples of just ways to integrate Wolfram language notebooks and Wolfram language code with HTML applications. Okay. I briefly went over this before. Again, you can do all the similar types of things you can in the cloud front end. I'll get into that a little bit. Again, one key little bit of a difference is which again you can run. Right now I'm running this from my local machine. So I have a manipulate, and we have the concept of publishing, basically making it available for other people to see. And so I've generated this manipulate on demand and just deployed it. If it pops up here, and I can update my slider here, and when I let go, it'll go fetch a new graphic from the server and then update. So again, just a little example of what I was talking about in terms of what the cloud brings. We have support for different notebook types in the cloud. So we have Wolfram Alpha mode notebooks as well. So we try to do that and support those types of things that we can do. Here is an example of something that I set up before, which gives some simple integer arithmetic and is showing all the pod results, in this case, different things. And again, it just sort of works, which is pretty cool. All right, let's see. Go ahead and solve an equation here for you. And then we can even look at the step-by-step solutions. Again, working very similarly as it does in desktop. Okay. And the experimental chat notebook types are also available as well. I won't go into those, but I think there's some other talks that maybe talk about that. So we generally support other notebook types. Okay, and one of the questions that always comes up is my notebook or is my fill in the blank supported in the cloud? And sometimes there's not a super great answer other than try it and see what happens, and then reach out to us when things don't work. But we also try to provide additional details in terms of the documentation and also programmatically that you can access through Wolfram language data. So again, back here on my desktop, I'll run this. So I get Wolfram language data of plot and cloud support status as the key, and it says it's supported. And then I'll pick another example of something here. Again, I sort of did some pre-work on some of these things. So geometric scenes, we do not support. And then here's another example for inset, which is partially supported. What does partially supported mean? Well, that's what the other additional key cloud support notes is for. And again, as I rerun this here, so we have a little bit of a note here that's based off of our implementation notes, and we update as we go. So positioning will not always match desktop behavior. It can be off by a few pixels due to font differences between the client and the server. And there are some other examples here. For one, financial data, which is partially supported for a different reason. So the inset one is partially supported due to sort of implementation details and in terms of the web, and financial data is partially supported for a different reason. In other words, in this case, you're allowed to use that within Cloud Notebooks, but you're not allowed to use it in cloud deployed forms or APIs in terms of being restricted. And then here's another example of another very powerful command and that you would normally be able to do on your local host. So run arbitrary processes, and the cloud support status says restricted in public cloud. And what does that mean? It can work if you have the sandbox disabled, which we'll talk about a little bit later. But again, run process allows you to run arbitrary code, and that's can be particularly problematic or malicious when running it in the public cloud when you're running in a shared environment. And so we restrict it. In other words, we block that, disable that ability to run in the public cloud. So that's a couple examples of the different sort of types of cloud support status. And again, this gets updated as you go, and is a really great way to sort of programmatically look at that. And that Wolfram language data is also sort of propagated into help documentation. So I'm not sure if you can see this through my screen here, but we have run process, and it has this restricted in cloud sort of marker there. We have similar other ones in the public web documentation. Okay. And again, just another example of working with deployed content from desktop. So I can Cloud Connect again in my desktop notebook here, and just sort of prove this to you. So the process ID is this, and if I cloud evaluate, this is basically sending off $process ID to be evaluated in a cloud kernel, so not on my machine. And it'll return back with something different, again, as I've showed before. So then again, it's really built to be utilized in a hybrid way in combination with using desktop, not as a replacement. And again, the other sort of types of things that make more sense in the cloud, which you can do these things in a local kernel. You can make a API function. And it's sort of inert and it sits there. When you cloud deploy it, what you're saying is, okay, I have this API function, which is just a Wolfram language function that I want to run. And the magic of API function plus cloud deploy will put this out on our servers so that you can utilize it yourself through whatever means you want with your API. So again, it's a very simple one, but this is really quite powerful. With 2 lines, I have a working API that I can use. So here I've gone to my API link, and by default, our cloud says, okay, we could not evaluate because you did not give an input. Okay, so if I give an input of x equals, I don't know, 100, let's see what happens. And then it factors it. So again, with 2 lines of code right there, could make it a 1-liner. I have a working API function that I can do. Again, a little bit of a trivial example there, but shows off the power for that. And we also have, again, again, sort of pre-built and wrapping around this to build certain constructs, in this case, a form function. So I'll show a little bit of an example here. Yeah, so probably speakers, but there we go.
Hello world.
Okay. Anyway, so I got a hello world in my ears. You guys probably didn't, but that was our little form function example. So I won't go into too much more detail on those. There's lots of documentation examples for that, and a lot of things you can sort of build up using primitives. In this case, allowing you to control the HTTP redirect behavior, or even specifically setting the response. So there's a lot of really cool things you can do, programmatically or semi-programmatically in Wolfram language to build up what you want to, again, tie into Wolfram language and utilize HTTP requests or other HTML. Okay. All right, so I want to review some key concepts of the public cloud environment just to make it clear what it is and isn't. So from a very basic general standpoint, we have Linux virtual machines. That's where your evaluations are running. So we run kernels and we run various front-end processes there for exporting. Currently, the public cloud does not have access to GPUs. There are per user limits on the overall storage. In other words, how many files you can have. And there's also per user evaluation memory and time constraints. And by that, we mean for each given evaluation, it can take up to X amount of memory or X amount of time. And as long as it evaluates within those limits, you're good. If it hits one of those limits, your evaluation will return failed, or will kill the kernel on you. And you can see those things via cloud account data. But just a reminder. So again, it's shared resources, and those are per user limits across that. As I mentioned earlier, we limit or disallow certain functions for security reasons. Primarily, these are around, like I said, run process to allow you to run arbitrary commands or things like that that would be problematic and to run in a shared space. And as I mentioned before, we have a combination of different sandboxing techniques to isolate execution of user code. So that means when you run your code, it's not touching or looking at or able to reach other people's code. But even with those sandboxing techniques, we still disallow certain things. And again, this is something that we are improving and definitely on our roadmap to do things like provide custom kernel environments where you can relax some of these restrictions and do other things before. And again, you can change all of those restrictions or set up your own GPU or different things in that sense, either in a custom or enterprise solution, whether that's you hosting it or coordinating with us to set up something for you. Okay. Next one. Whoops. Sorry. Another key concept to talk about is the kernel types. So there are primarily two kernel types in the public cloud, Wolfram public cloud, what we call session and public. So a session is a long-lived kernel assigned to a single user, typically when you're editing a notebook. This is pretty similar to the default kernel configuration when you fire up your local Mathematica or Wolfram installation. You have the same kernel that is shared across your front-end session and across your notebooks for the life of that kernel, or unless you start a new one or do other things like that. And that's, again, used when editing a notebook. The public kernel is a short-lived kernel. Again, it's assigned to a single user, and it's typically for a single evaluation. So the biggest difference here is long-lived versus short-lived. And the public kernels are what you're going to get when you saw my API function or that form function. Because again, they're basically a one-shot evaluation. It says, okay, I will configure this kernel for this user, load their code, and then I will execute it once. And then I will, that kernel will essentially be done for that use. And if you visit your API function again, you're going to get a different kernel. We also use these public kernels for when you're viewing or interacting with deployed notebooks with a little bit of caveats. And this is something that might change a little bit in terms of having a different kernel type that's a little bit in between public and session, particularly for viewing deployed notebooks, because that's another case where you want a little bit longer lived kernel, so you're not always switching back and forth between a new kernel when you're moving your manipulate slider. And that is something that is in active development, but we also want that to not be as long lived as your typical session ones. So just a reminder, there are different types of kernels, and depending on what view you're in is where you'll use these. And that's the next thing that I'll talk about is, tied to the types of kernels is the concept of views. So cloud notebooks in particular are cloud objects, and like all other files in the cloud. And the cloud object system is what allows us to, map the contents of your cloud object to a specific URL, whether that's viewing and rendering a notebook, whether that's executing an API. Everything is part of that cloud object system. And cloud notebooks themselves are usually distinguished by MIME types from different things. And how a given cloud object is displayed when accessing it via the web ultimately depends on the view, which will hopefully make a little bit more sense in a second. The view is determined in the following way from a high to low precedence. So the highest precedent is if you explicitly add a query parameter in terms of specific view. The next one is the path prefix. This is the /env or /obj, which you've probably seen. And then underneath that, there's a default view that's associated with the type of object. So notebooks by default go to this deployed notebook view, which is the OBJ. Same with API functions, if you saw that before. And I'll show you in a second what this means. So typically, you don't usually need to worry about specifying this explicitly, but you can do so using the cloud object URL type option to cloud object and related functions. So in this case, I'm creating a dummy object called my object, and I'm going to say, show me the environment URL when I display it. And a key thing here is just because I asked for the environment view doesn't mean that the other view doesn't exist, which again, I'll show you in a second. So I'll create this. It gives me the environment view. Whoops, that's because I didn't do the right thing. Let's just do because I didn't make a notebook probably. That's what I get. Let me switch back to here. And so this was my other notebook that I created. And as you see here, I have the env. And if I just switch that to obj, you get a bit different view. So this is the deployed notebook view where I'm going to view it. I can't edit it, but I can download it. I can do these other things, and it still displays. And if I had to manipulate, I can interact with it. If I want to edit it, I switch the views. It's the same underlying object. And so let's prove what I just said. I'll make a manipulate of plot sine of x in a from 1 to 10. Okay, and if I switch back over to my OBJ view, it's going to take a little bit in a minute. There it is. And again, I can't edit, so you can't see this. I'm clicking, I'm typing, nothing's happening, but I can work with my manipulates, and that is the primary difference. Okay, and that's specifically for notebooks. Again, if you saw me earlier from my API function, by default, it was also into the OBJ view as well, the deployed view. All right, let's go back to my example. And again, as I just showed, the most common switch is between the environment that allows you to edit it and the deployed view that allows interaction but no editing. Okay. There are some other specific details around that in terms of the environment view is tied to the session kernel, that long-lived one. And the deployed view is generally tied to what we call the public or the short-lived kernel. And there's a lot more details here that you can get into on this link here, which talks more about general architecture, concepts of our editor, different things there as far as notebooks, how pre-rendering of deployed view works, dynamics, graphics, the section I just showed around views and types of kernels even goes into a little bit more about permissions. So I definitely encourage you taking a look at that to explain more details on that. Let's see. Okay, and then one other key thing to remind people is that the front-end kernel communication overhead is much higher in cloud. So the browser is communicating with the kernel over the network, and you need to understand this in order to reduce typical front-end to kernel communication to make things sort of performant. And you probably saw this in terms of latency on the manipulate there. And again, it's just different. In desktop, you have essentially zero latency because typically the front end and the kernel processes are right next to each other. One way to do this is hook up your link snooper kernel configuration output in your desktop kernel session, and you can see how much communication there is between the kernel and the front end for your given notebook or mini application. And the key is you want to eliminate as much of that as possible. Let's see. I guess I'm following up. Increasing the fonts on either the presentation or when I'm in my when I'm actually in the Wolfram Cloud view. I assume it's the latter, and I'll try to do that when I do the next one. Okay. One key interesting thing that we do is incorporating these cloud notebooks into other websites, and that's through the notebook embedder, which is a JavaScript library that allows you to seamlessly integrate public view notebooks for that. So here is a quick example, and I will try to zoom in a bit on this one. So this is a cloud object that I have in the env view, and it's actually an HTML file that I can edit. And I've taken this from the examples from the notebook embedder, so people can look at those links as well. And so it's an HTML page that I can edit and do something live right here. If I switch to the deployed view, that's going to render it as HTML. And I had a chosen one here. So this is basically an example of how you would utilize the notebook embedder. This notebook should look familiar. It's the one I just created and edited. So that's loading the static HTML. And then if I click, embed live notebook, it'll go ahead and do that. And that's what it looks like. And if I go back down to my Zoom for that, so I can change that in real time, either by putting in something different here. So for example, I copied a notebook from Vitaly from community earlier, and then I made this public, get my link, and then I can go back to my example and then do the same thing there. So that's what's happening in real time. And so this is my HTML that I created there. And then I can even switch that if I wanted to go back to the default. So instead of starting with the example that I gave, I can go ahead and start with the one of my copied notebook from community. And again, just switch, and that's there. Whoops. Did I not save that? There we go. And you can see that I've edited the HTML in real time and did that and can incorporate my server-side rendering there. All right, so that's a really powerful thing. There's also additional sort of endpoints that allow you to view and render notebook content by given a URL or a direct expression. So this example here, I'm providing a URL to again a publicly accessible notebook that happens to be over here. It could be somewhere else, as long as it's publicly reachable, a notebook file, I can do that. And so I'll click on this link. And then what it does in real time is it goes and pulls that notebook file and then tries to render it. There is some amount of caching there, but this is an in-memory notebook that only lives for the life of while I'm viewing it. The other example that I gave is when you specify a notebook expression directly, And again, notice it's percent encoded here. So we get a notebook, and that's my sort of hello world one. Okay, so getting close on time here, so I'll sort of go ahead so we can still get to some questions. There are a ton of applications that we built on top of this, and I'll just run through these kind of briefly. Our custom GPT is extremely powerful. It builds off of all of the capabilities of the cloud. You can execute Wolfram language code, doing that pretty safely. Extremely rapid prototyping and deployment. Literally, we were updating prompts and redoing things by the minute. And we have similar APIs and integrations with other LLMs and a lot of custom solutions around this too as well. The resource system that Stephen talked about in his keynote yesterday. This is entirely built and served out of the cloud. So, for example, the function repository pages you see here are actually cloud objects, and there's a set of API functions that back it that do different options in terms of submissions and form functions, etc. Community, as I showed, again uses the notebook embedder and just showing and sharing notebooks. And there's also the Wolfram Language Playground, which also uses the notebook embedder to provide a sort of a sandbox to evaluate and experiment without requiring sign-in. And Wolfram U is also built utilizing cloud notebooks and serving things as cloud objects in a combination of HTML and other things. And we have a ton of other internal and customized applications that are more sort of server-side based, including custom ERP solutions, log analysis or task systems that are basically, again, deployed tasks or deployed API functions that utilize Wolfram language to run long learning processes. And we also use internal development instances for things like developing the next version of Mathematica and cross-team sharing of materials, like I said, directly of notebooks or even just agendas and other things in the company that's been very successful. All right, super quick run through of roadmap and priorities. So again, we still have a long way to go to try to be at parity with the desktop. There will always be some differences and limitations in terms of performance. We definitely want to overhaul our editor to give more features there, have improved code assist features, and continually care about performance improvement, particularly around dynamic and manipulates. Cloud objects, again, just general performance optimization and better support for cloud operations, as well as improved documentation and workflows. Our enterprise support is drastically improved and getting there. Containerized cloud is coming soon. For more information, again, as I linked the notebook features, we also have our release notes, which shows all of the releases and gives details for that. And then I have the most up-to-date version of this talk, which is itself a cloud object. And I'll skip my summary because I want to at least give a little bit of time for questions.